Swayam Prabha. Digital India. Educated India.
Now, let us go on to PERT. So, like we said, the people who developed PERT faced challenges in computing powers. So, they decided they should develop some kind of a technique which can model uncertainty and at the same time be a closed form kind of a approach. And this was initiated, as you can see here, for the Polaris missile project, okay, by the US Department of Defense. And this, as you can see, is a defense project. If you are going to build a Polaris missile in the 1950s, there were a lot of uncertainties, and the project could not be delayed by a large number of years. So they decided they wanted to kind of take a CPM like technique and try to bring uncertainty modeling in it. Okay, so this was done, like I said, with the US Department of Defense along with the consultants Booz Allen Hamilton, and they were very successful in having developed and deployed the technique, and they are reported to have saved 2 years on the project duration by using a PERT approach. The original paper by the developers of PERT is available online. I will be giving a link to this in the handout page, and for those of you who are interested in getting into more details, I would recommend that you can read this, because you will understand the thought process and the case study they used when PERT was originally developed. Now, a little bit of background on PERT. So, like we have been discussing, PERT will try to represent probability by an expert estimate. So, we do not have data. Remember that the project we are doing it is most likely for the first time. We do not have any historic data in this case. So, the PERT developers had to go with an expert estimate. Okay, there was no option. And when we go through the technique, we will see that on projects which are really novel, this is fairly a good way to start off. Now, after you get this estimate and you represent the uncertainty with the appropriate distribution, PERT uses basically the CPM type of forward pass, backward pass analysis. So that way it is very familiar process to, as per CPM, and you will see that the network diagram is also almost the same. It is actually exactly the same, and although the CPM was what developed the network diagram first, the CPM diagram is the network diagram is very popularly referred to as the PERT chart. So it is if you look up Google and say PERT chart, you will get the network diagram, and even in practice most people use the term PERT chart to refer to a network diagram, although it was the CPM developers who originally brought out the network as a way of planning. Now, the last point you have on the slide is that yes, doing PERT is not certainly much more challenging than CPM, because we are trying to deal with uncertainty based issues. And as we discussed in construction, most of the activities we do are not really that novel. We should be able to get reasonable time estimates on it. We might have historic data on it. We should be able to estimate our durations with a reasonable amount of certainty, and given that and that the overhead of PERT is quite high, you will find that PERT is not widely used in construction today. Like we discussed, some of the other areas which have a large range of uncertainties might be using PERT, but construction does not use it widely. Now, when we go forward with this lecture, okay, I will be presenting PERT using the AON representation, because that is what we have been familiar with and we have used in most of the other lectures. The original PERT developers used AOA. Okay, they used the activity on arrow technique, which is still the default for PERT. Okay, we don't see too many references with AON and PERT. There are some references, but most people would still use AOA. But I am going ahead with the AON representation because that is what we have used throughout this lecture. And I do not think there is too much of a concept loss if we continue to use AON, and I think it will be easier for you all to follow. Now, let's take up the assumptions of PERT. So one of the things with PERT is there are several assumptions. Okay, so we have to understand that these assumptions also cause a lot of limitations in the applicability of PERT, and that's another reason it's not that widely used, because the values we get are not too meaningful. Then why go through the whole process? But starting with the assumptions, the first assumption is basically on the estimate at values, how we actually convert this into a duration. So as you can see, this is a quote from the original paper. They say the assumptions that a standard deviation could be adequately estimated as 1/6 of b minus a. So that's one assumption which is there in PERT, and we are using a beta distribution. So they have given the form of the beta distribution that's being used. They are assuming that it's an adequate model for the distribution, and based on this distribution and this standard deviation, we get the basic two formulas in PERT, which is very widely used, which says that, okay, which is here, that's the expected time is equal to the optimistic time a plus 4 times the most likely time m plus b, the sum of all this divided by 6 will be the expected time. Now similarly for this distribution, the standard deviation is given the pessimistic time minus the optimistic time b minus a divided by 6, and we know that the square of the standard deviation is a variance, and this is the variance equation, which is just the square of the standard deviation. So what we tend to see in PERT as a standard formula for the PERT activity and the PERT standard deviation, calculating the activity and the standard deviations itself, are the first assumptions which the authors of PERT have said that they are making. As we move on, the second assumption in PERT is that the central limit theorem is applicable. Now this is a very basic statistical theorem, and what the central limit theorem says, that if I have a set of activities, or the way we would apply to PERT is, if I had a series of activities that we have earlier seen that each of these activities will be modeled, the duration will be modeled with a distribution, right? You can see the distribution here. I said it is going to be modeled with a distribution, and we know that this is not normal distribution. This is a beta type distribution or a PERT distribution. That's what we are going to model it with PERT when we use PERT approach. And what the first point in the central limit theorem says, the distribution of the sum will be approximately normal regardless of the individual distributions. So as I go down this link in the network and I calculate my early start, early finish, and I sum it up and I go down here, I might be taking specific values from not normal beta distributions or other distributions, but in the end when I sum up, the distribution at the end is a normal. Okay, my project duration will have a normal distribution, although my activity durations here can be a beta. So this is basically what the first point says. The second point says the mean of the sum is the sum of individual means. That means when I calculate the mean of all of these values, so when I come in here and I add up here is the early start, here is my duration which I calculated, I get 7.8, here is the early start of B, the duration is 15.7, so I get my early finish, and so on, and here I get my project duration, end of D is when I am ending, 39.2, so my mean of this normal distribution will be 39.2. So basically the mean of the sums is the sum of individual means. Okay, so here is my mean value, that is going to be 39.2. And the third point says variance of the sum is the sum of individual variances. So as we saw earlier, we had the standard deviation and we squared the standard deviation to find the variance. So here I have various variance values which I have put here, and if I sum these variances, so the variance will give, the sum of the variances will give me the variance to this distribution, okay, and the root of this variance will give me the standard deviation. So by the end of this exercise, I have characterized my normal distribution. I have got a mean of 39.2 and a standard deviation of 2.31, and once I characterize this with these two values, you know that we can do a lot of computations based on the standard normal curve. Okay, so you might wonder how I got these values. They are they are basically values which I have substituted from another problem. I have not given you the base values to be able to get this, so don't try to calculate this. I just wanted you to illustrate with these values to show how the central limit theorem is applied. Okay. So now we go on to the third set of assumptions for PERT. Okay. The first point here is that there are enough activities to make the network path to make the central limit theorem valid. So remember that for the central limit theorem to be valid, if I have one or two activities, if I had just one activity, obviously the duration will still remain to be a beta distribution. So we need a large sum of or large set of activities down the network for the distribution for the project duration to be normal. So that is the first assumption, that there are enough activities in the network to make the central limit theorem valid. The second assumption is critical path is long enough in time so that no overlapping distributions and are there, and the distributions are assumed to be displaced. So if you have overlapping distributions, computation of PERT probabilities don't become valid. So this is quite a limiting assumption, especially when you have multiple critical paths which are close to each other. And in case there are two or more critical paths, then the larger variance would be deemed critical. So PERT does not take into fact by default the fact that multiple critical paths can exist and there can be overlapping durations, overlapping distributions here, which will then cause, one critical path can be critical at some time and other critical path another time, and this is certainly a limiting assumption in PERT. Now we will go to the stepwise procedure for PERT. Okay, so typically when you are given information to do a PERT value, we will not start with trying to make an expert estimate because that is beyond the scope of this course. We will typically give you the activities and predecessors like in CPM and 3 estimates of duration. Okay, so we will give you the pessimistic, the most likely and the optimistic as 3 estimates for duration. So once with this information, the first thing you can do is draw the network, which is very similar to CPM. The second step is to be able to calculate the expected value for each activity, and we have seen this formula before. Okay, this is pessimistic plus 4 times most likely plus optimistic divided by 6, and you will calculate the expected value of duration for each activity, and then the standard deviation of the activity duration using this formula here, and the variance, which is just the square of the standard deviation. Now when you go to step 4, basically we will use this expected value, okay, for each activity, and we do the forward pass and backward pass and calculate early start, early finish, late start, late finish, actually late finish and late start, as we did for CPM. Okay, so this is very similar to the CPM step, except that we are using the expected value. And in step 5, we, just as again very similar to CPM, we determine the critical path and the project duration. And now we should realize that although we have a project duration, but this duration is not a single value, but it's the mean of a normally distributed project duration. Sure. So this, when we did CPM, we did not have any more information other than that single value. Here we have not just a single value, but that single value represents the mean of the normally distributed project duration. So this is a very important aspect. We now go to step 6. Here we have to calculate the sum of variances of activities on the critical path. So this I will illustrate in the example. So we take, once we have calculated the variances, we take the variance of only, we sum the variance only along the critical path, and this sum is actually the variance of the normally distributed project duration. Okay, so in the earlier step we found the mean, and here we have found the variance, and from the variance we find the standard deviation, and so now we have actually characterized the project duration as a normal distribution with the mean value and the variance. So once you have characterized the normal distribution with the mean value and variance, we are then be able to use the z value tables, okay, to calculate either probability values associated with the given distribution or the duration values associated with the probability. This also we will illustrate in the example as to how these are done. But basically these 5 steps form the core of, these 7 steps form the core of your PERT procedure.